I wanted to go over this particular question of finding the absolute min over a restricted domain when x is greater than or equal to 0, but I'm within a circle of radius root 3 of some function xy squared. So the computational domain that we're dealing with is x has to be greater than or equal to 0, so I'm dealing with this side in that circle. X squared plus y squared is less than or equal to 3. All in here. This is my D. It includes this part of the y-axis, this part of the x-axis, and it includes, of course, the boundary as well. So the minimum either occurs at a critical point within the boundary D, or it occurs along the boundary itself. Now, the first thing to get critical points, we're going to look at when the gradient of this function, x times y squared, is equal to 0. So the gradient of this function is the derivative with respect to x, which is y squared, and then 2xy. Now, in order to be a critical point, either my function's continuous, but the derivative is not defined, which that doesn't happen in this case, or the derivatives are simultaneously equal to 0. So y squared is equal to 0 only if y is equal to 0, but that automatically makes the gradient 0 in the second component as well. So my critical points are all along the x-axis. So everything along here is a critical point. Now, when I look at my function, I see that the value all along this line, or this line segment, is f is equal to 0. Now, since there's no other interior critical points, we're just going to look at the boundary to see if there's any lower values than f equal to 0. Maybe f equal to 0 is the absolute minimum. And so if I look at the absolute minimum, I have possibly it could be 0. All along this boundary right here, if I know x equal to 0, that would also have f equal to 0 on that function. And then along this boundary, we can think of the equation for y along that boundary is equal to 3 minus x squared and the all square root of that. And so along the boundary, so I'm going to say along x squared plus y squared equals to 3, my function x of 3 minus x squared is equal to x 3 minus x squared. Now that's a 1D function, and I'm going to just expand it, and I have 3x minus x cubed. Now, this is a 1D function, and I can find critical points for this particular function. Notice the x value, x ranges from 0 all the way up to root 3. And so I can try to see when does this function reach a minimum or maximum value in this little interval. Well, I'm going to call this function g of x. And let's just look at g prime of x. That would be 3 minus 3x squared, which equals a 0 when x is equal positive negative 1. Now, looking at the second derivative, which is minus 6x, we see that when x is equal positive 1, the second derivative is less than 0. So in other words, the second derivative evaluated at the only critical point that's within this domain, x equal to 1, is equal minus 6. It's less than 0. So must be at 1, x equal to 1, we have a max. So we actually have found out where the absolute max of this function is. It actually happens when x is equal to 1, and going and putting back in here, if x is equal to 1, then y is equal to root 2, and my function would have a max value of 2. So let's just label that on the graph. If I was at 1, I'd have 1 root 2, and my function height would be 2. That turns out to be the absolute max of my function. But now we have indeed determined that the absolute min is f equals to 0. So this is a case where we have to really look hard on the boundary to investigate, see if we have extrema on those locations.